Hello everybody, I'm very pleased to welcome you to our webinar dedicated to the inSSIght project and on the topic, the keys to success in engaging the AI revolution with smart solutions. I am Géraldine André-Augustin, the CEO of BlueMorpho. So what is BlueMorpho? It's an innovation accelerator dedicated to companies who wish to generate value in adopting disruption in deep tech, digital and smart systems. We are a happy partner of the inSSIght project. inSSIght is an European project. It's a coordination and support dedicated to help the smart systems community to increase its market access and to further engage smart systems into new products and new applications. So this inSSIght webinar is dedicated to any company who wants to adopt smart solutions and smart products and to be part of this ecosystem. Just to explain what is a smart systems, for us, the definition of a smart system is a system that is able to sense and act with its environment. So as you can see on this slide, it's a combination of sensing, actuations, but also energy management and storage, data communication, and in the middle, you have knowledge base and processing, which is basically a part already of AI solutions here, artificial intelligence. And in smart systems, it's fully integrated. And this is really the value of smart systems. Today, we want to discuss with you the keys to succeed in engaging the AI revolution with smart solutions. And I'm very pleased to welcome our experts today that will share their feedback, their analysis, and their experience in going through this AI revolution. So I'm introduce you Johan Chudi from Your Development. Johan is software and market analyst with very in-depth expertise in AI. So hello, Johan.
Hello. Thank you for inviting me.
Very pleased to have you. I'm introducing you also Stefan Wolf, consultant at VDI IT. As you will see, Stefan has also a great expertise in AI and will give us a focus on the energy application. So hello, Stefan.
Hello to everyone.
And we have the great pleasure as well to have Jonathan Byrne, data scientist, senior software developer at Movidius Intel. So Jonathan will share with us also the experience he has acquired at Intel and Movidius in developing AI solutions to address the needs from the industry. So hello, Jonathan.
Hello, everyone.
We have key experts here. This webinar is dedicated to be very interactive. So if you look on the right part of your screen, you have a question box. So don't hesitate to ask all your questions here. We will answer you at the end of this webinar. And if we don't have time to cover all the questions, we will answer to you later on. This webinar is also very interactive. So we are very interested to know more about you. So I'm going to ask you a few questions, and you'll see it's very easy to answer. So my first question is, how would you assess your level of knowledge of smart systems solution? So you can see here on the screen, just answer us. If you consider that you have a low to high level of knowledge in smart system solution. This information is very useful for us because we can provide answers to your questions in the best way. So we need to know who you are. Okay, so actually we have for the moment rather, yes, just 2 seconds more for the people who haven't answered yet. But we have, most of the people know, are not very experts in smart systems, but you seem to get interesting to know more about it because some of you don't have any knowledge of smart systems. So it's quite interesting. My second question to you is, how would you assess your level of interest in smart systems from low to high? So, as I said, rather very strong interest in knowing more about smart systems, and we hope also considering adoption of smart systems. That's why also we think it's very good and very important to link smart systems with AI, which is a current trend. Thank you for answering, and I will almost done with my questions to you. We want to know also where you see the main added value of smart systems. Is it on autonomous solution, connectivity, intelligent solution, new sensing functions, and also to open new markets? So it's going to be my last question to you. So just take 2 seconds to answer, and then we can start asking the question to the experts. So just 2 seconds more for people who haven't answered yet. And okay. So what we can see here on this, the answer to the questions is that a lot of people, I can show that to you, are very interested in autonomous solution and opening new markets, but also the intelligent solution. So I think this is something very interesting for the speakers today, for the experts, to know that this is also why people are interested in smart solutions. So you can also highlight this point during your presentation. So why this topic? This topic, it's because we want to showcase that when we consider AI, it's not only software, it's a lot depends also on hardware. And it's not because we are coming from the smart system part that we are saying that, it's because it's fully coming from the experience. And what we would like to do also through this topic is to share best practices to really success in and with AI. So my first question will go to Johan. So you will see during this webinar, I will ask questions, but please, participants to the webinar, ask also your questions, because as I said, we want this webinar to be very interactive. So Johan, you're expert in AI. Could you give us your point of view on how this AI revolution is impacting the chip makers industry?
Hi, Geraldine. Thank you for this question. Can you share your screen, please? So I can answer with the
yes,
slides.
Sorry, because you're still on the questions. Yes, absolutely. Yeah. So
yeah,
it's
better to answer with some slides. And so at YOL, we have worked on this topic since 1 year and a half now, and we have made a strong focus on AI, particularly for consumer. Okay, in the consumer business and the automotive business too. So in this webinar, I will particularly focus on the consumer business, and just to say that the link between software and hardware is not new. If you look at the citation from Alan Kay, it was made in 1982, so a long time ago. And he was saying, already at that time, he was saying that people who are really serious about software should make their own hardware. The idea of linking hardware and software has been lost during the, let's say, 20 last years, mainly because hardware was enough powerful to run any software we wanted, thanks to the Moore law, for example. And the second reason, which is not as obvious, is because the languages for developers, sorry, has a very high level of abstraction. And when today you ask to a software developer if he cares about hardware, he says, no, the languages make it for me. And this is changing today and will change in the future. The reasons are multiple. The first thing is because the Moore law is ending. Clearly, we have seen that since 2 years. It's more and more difficult to build more transistors in the same space of silicon, and this makes a question: how can we still have the same powerful hardware and continue to grow this trend without the Moore law? One trend that we can see today, particularly in the smart era, is the specialization of the hardware. So today, when I'm talking about specialization, is to relink the software on the hardware. Today we have hardware which is dedicated to run a particular algorithms particular pieces of codes. If we look, for example, at the neural engine in the last iPhone 10 and what we are seeing today in the last smartphones, this accelerator are dedicated to run a neural network for artificial intelligence. Artificial intelligence is impacting this trend very heavily because artificial intelligence algorithms are very greedy and we need power to run these algorithms. So when before we didn't really take care about hardware, today is not true anymore because we want a powerful hardware to run artificial intelligence on the edge. That's a trend for multiple reasons. I will not enter in the detail today about why we have this trend from cloud to the edge. But the main reason is because we still want powerful hardware, we have to make a specialization of chips for the dedicated algorithms. So if we look at the market in terms of software, we can look it in two ways. We have imaging, artificial intelligence, and audio AI. This is the two main trends. We can speak a lot of other domains, but either the technology is not ready for olfactometry, for example, or taste recognition, or we don't need AI for some application. If you look at motion sensing, for example, we don't really need AI for today. So this is the two main trends in artificial intelligence today in software. And in hardware, we can observe two different trends too. Either the piece of hardware that runs AI is embedded in a chip, what we call a SoC, or an application processor. And you have just a small part in the chip which is dedicated to run the AI algorithms, or as it is done classically, we have a standalone chip. Everything good? Okay. So this is the two main trends on the hardware side. If we look at the systems for the consumer, and I will enter in the detail maybe later, we carefully looked at the smartphones, obviously, which is the biggest market today, impacted by artificial intelligence. We have looked at drones, and we have looked at what we call robotic home or robot homes, which is just a smart home with artificial intelligence system in it.
So that will be my question, actually, Johan. When you see the different the segmentation you introduce us in the audio and the image on the other side, what is the impact at the hardware level? How does it mean for hardware solution?
Actually, that was a very tough question, and the only thing that we had until today is what happens in the last 10 to 15 years in imaging. Okay, that's the basic. We have seen what AI has made at the hardware level in imaging, and for audio we have made the assumption that we will see the same kind of behavior in the hardware. So if we talk about imaging, AI for imaging is to understand the environment around the device. And whether we have what we call a vision processing unit, which is embedded in an application processor, as I said before, or we have a vision processor, which is a standalone chip, which is dedicated to make an analysis of the image. It's not just today, that's very important too, just to remember that before we were not analyzing the image. It was a processing of an image, and that changed completely the model of the architecture of the chip today. And if we look at what will happen soon in audio AI, we will have both type of hardware too, sound processing units, so embedded in a SoC, system on chip, or a sound processor, which is the first things that will appear on the market soon. And why we need audio AI too on the software side is because the interaction between man and machine in the future will be made by voice, by audio, and we are already seeing that with VPA today.
Right. So it's really also following the trend from the application side.
Yeah. So
Okay.
if we make a bit of expectation of forecast, and again, it's very difficult to forecast such hardware types because nothing exists today, and the only example we have is on imaging, like 3, 4, 5 years from now. And so what we are expecting at Yole is two things. First, for imaging, the market will be driven heavily by what we call the robot home, with cameras inside your home that will recognize yourself, that will recognize even your pet, or it's for security reason, or for mainly comfort. And the second thing is smartphones. Okay, you will always have artificial intelligence for imaging in smartphones, for example, biometry, for photography, for augmented reality, for example. So you will have this type of hardware in your smartphones. For audio, the main market driver will be the smartphone too, with a sound processor dedicated to compute audio AI algorithms. So if we look at what we are expecting, it's again a 20 to 23 billion market in 2023, which is, I mean, huge, really.
Yeah. Okay. So when you look at that, for you, and I think this is a summary of what you just said now, it's what are the market segments that will lead this AI revolution?
So as I said, we have three markets. The first one is the smartphone. The second one is drones. But drones, I will say when I will talk a bit about later why we have looked at drones. And the last one is robot home. So if we look at smartphone, we have two kind of applications, so imaging and audio. So imaging, if you look at what are doing players, Apple and Huawei are leading this AI market, let's say. Apple more on the security side with the biometric authentication, and Huawei has made the bet to focus on photography, which for us really it's a good one. It's a good bet. If we look at the other players of that build application processors, so Qualcomm, MediaTek, they are still a bit behind for us because they are optimizing their existing hardware to run to be able to run artificial intelligence. They have not, as I said during the introduction, they didn't build completely dedicated architecture to run artificial intelligence for imaging. In audio, very hard to say. It's just the beginning. So the first chip will be probably released in 2019. But now, and this is pretty clear too, this is a very good differentiation technology. And yet we don't know if this architecture will be embedded in an application processor or if we will have a standalone chip. For now, we imagine that a standalone chip is still better. If we look at the second market, so drones, why we have looked at drones? Drones is a very interesting market for one particular reason. The thing is that drones is kind of between the automotive market and the consumer market. We have requirements from the consumer market, but we have power from the automotive market, let's say. And it's why we have looked at this market, which is and maybe we will see that later with Intel Movidius talk. A very nice one. So we have low power consumption, energy efficiency, but we need very heavy computing efficiency. And the last one, which is robot home, it's the convergence of, let's say, 4 or 5 different types of systems where we can see VPA, so virtual assistants like Google Home, Alexa, and robots, mainly for security, like what we can see with cameras, where we have some nice things for elderly people that can be helped with robot companions, maybe telepresence too, and companion robots, which is the new one and a very huge growing market today.
So we spoke a lot about hardware, but what about software? Who are the players?
Okay. In software, the business model for software is completely different. Today, what we can see for, at least in artificial intelligence, okay? If we look at AI companies in software or startups, their business model is quite interesting. What they want is not to get, let's say, a 10 to 15 years company. What they want is to get funded very quickly, and to be sold or to have a huge investments in the first 3-4 years. So if we look at these investments or acquisition, we can see that we have let's say, big battle. This big battle is between what we call the GAFAM, so Google, Amazon, Facebook, Apple, and Microsoft, and on one side, and Baytix on the other one, with Beidou, Alibaba, Tencent, and Xiaomi. The culture is completely different. While we can see that American companies are acquiring these startups, Chinese companies are more in the, let's say, investment business. They are trying to let this startup grow. And two different culture. But the thing is that it's very interesting to see that, but actually there is not, let's say, one side that is better than the other one. We can't judge very quickly on that and very well on what is happening today. Let's say that there is a huge amount of money that is coming into AI software today, and particularly with these two different trends.
Right. So today, what will be the key messages you would like to share with the audience?
So
to just summarize a very interesting presentation.
I will summarize very quickly about what is happening today in the artificial intelligence hardware ecosystem. If we look at what is happening, we have two types of different way to think about hardware. We have the companies that are used to be known to be close to sensors, companies so Sony, Knowles, AMS, On Semiconductor, and what they want is to build hardware close to their sensor. It's kind of decentralized computing, okay? Still on the edge, and it will be, as I said, and I insist on that, it will be specialized hardware. On the other side, we have companies that are trying to implement artificial intelligence inside a system on chip, inside an application processor, which is not fully dedicated to compute AI, okay? In these companies, we are seeing Qualcomm, Apple, NVIDIA, HiSilicon, all these guys. Behind that, we have IP companies that can sell to both types of systems, okay? So Siva, Imagination from Xperi, or ARM. And finally, we are seeing and this is a very interesting trend since, let's say, 2-3 years, this GAFAM and Baytix entering this hardware ecosystem. So the question is why are they going into that business? And obviously, the first answer to that is the opportunity to make money in hardware AI is huge, and the impact of artificial intelligence on the semiconductor industry, particularly for computing, is huge. And this guy, they understood that a long time ago already, and it's why they are going into that business. And the second thing is obviously today there is a big war around data, because data is money. Data it's the new currency, data, and getting the data directly from the sensor and be able to handle the data from the sensor to the final, let's say, output analysis, obviously is a key point. And the company which is able to handle the data from the beginning to the end, they probably will win the data war. Thank you.
Right. So do you consider that we will see a concentration of the market and the business in the coming years?
I mean, to be able to build AI hardware, you need to have either what big investments. So as we can see in Israel, we are seeing a lot of startups that are building ASICs, for example, around AI, and they need heavy investments. And the thing is that to build artificial intelligence hardware, you need to have thousands of years of R&D. So yes, we will clearly see a concentration. At least we will see a few numbers of companies that will be able to build this type of hardware, for sure.
All right. Very interesting. Thank you very much for this very good presentation. Very also a good focus also on consumer application because it's also a very strong driver currently. I've seen that we have a few questions about your presentation, but what I suggest we answer that at the end so we can have a look to that during the webinar and come back to the answer to those questions. And meanwhile, I like to make a focus not on consumer application, but whether on industrial application with the field of energy. How AI is used on the energy field. And for that, I'd like to welcome Stefan Wolf from VDI/VDIT, who had a very good look and good analysis on this topic. So first, I'd like to ask you, Stefan, what gets you interested in making this analysis and spotlight on AI for energy applications?
Yeah, thank you very much for the kind introduction. And well, I'll talk today a little about the application of AI in the energy sector. And we have a background here of working in lots of consulting projects with a focus on digitalization of the energy sector. The energy sector at the moment is really shaken by two very important game changes. The most important for sure is the climate change mitigation, because 75% of our greenhouse gases are emitted by energy or fossil fuel consumption for energy generation. And that leads us, if we proceed that way, to a world that will be 4 degrees warmer than before the Industrial Revolution. And that's pretty much, that means all the corals will die and lots of ecosystems won't be the same as we know them. So that's why the EU aims at a 27% share of renewable energy in the system and a 40% cut in greenhouse gas emissions. And what this magnitude of the task we have to take on is, you can see on the graph on the right side, where the CO2 emissions are shown we have seen so far, where you also see the path we need to take to accomplish the Paris climate agreements. And this is quite a turnaround we need to fulfill there. And the good thing is that there's also the digitalization happening in the energy sector. So this gives us a lot more data, and communication technology allows us for installing sensors and controllable devices all over the energy system. And this enables new digital business models that are built on data. And here AI comes into play, because we have a far more complicated energy system in the future, and this need to be controlled in a very intelligent and highly automated way. So in this diagram here on the left side, you see the traditional old-fashioned energy system, which is organized hierarchically, and we have nuclear and fossil fuels as main energy carriers. So this needs to be transformed into a more efficient, decarbonized, decentralized, and digitalized system, where you have lots of different applications like storage and consumers, like energy generation from wind power, solar power, and so on. And this all is connected through the energy grid. This leads us to enormous it's an enormous task to be accomplished, because all this has the effect that volatility of energy flow will be increased a lot. We have an increased complexity of energy management and an increased need for a more flexible energy system. And that's the point where AI and digital services will be needed deeply.
So it's really interesting because in the presentation from Johan, we have seen also that it's very driving by its technology push, so making the technology more possible for new functions in the iPhone, as an example. In your explanation here, we see it's really a market-driven, it's market pull, actually. So the use of AI will be really driven by market needs.
Yeah, exactly. So in the energy sector, we have this huge task of becoming fossil fuel free until 2050, and this means that the whole sector, the whole way of business works has to be transformed there, and that creates a huge need for new technologies.
So if you look at the different challenges that you will address with AI, can you give us a bit information here?
Yeah, I'll do. So there's a huge demand for those digitalization projects in the energy sector. So we have the implementation of smart grid components like smart meters, controllable power transformers, etc. We need to see new communication infrastructure like smart meter gateways, like power line communication, or long-range wide area networks to get all those sensors all over the energy system into our data infrastructure. Then data management and data governance is deeply needed. So we have there the smart grid architecture model, which helps us to organize those future smart grids. And we need meter data management and lots of other tools to manage all the data we need to collect there. In data analytics, we need signal, event, state, engineering and operations, and customer analytics. So all this data that will be collected here needs to be analyzed. And we need data-driven decision-making for peak shaving, load shifting, storage management to, let's say, manage the energy system to let it work in this decentralized new system we are building at the moment. There's lots of decisions needed on a daily or secondly basis, and all of these decisions need to be done rapidly and in the most automated way possible. And here's a great application field for AI. So AI is needed for pre-processing of data in smart systems before they are shared with other services. In organization and structuring of data, in data analytics, and especially in the detection of irregularities, for example, in predictive maintenance. In predictive models for maintenance, but also for energy forecasting, because energy becomes a lot more weather dependent, and that needs to be included into the energy management. And the automation of routine decision making. So those are the main fields of AI, and later on I will give you some more detailed examples.
So how is it used on the value chain?
Yeah. So on top here, you can see the energy value chain from generation all the way to customer service. And here I put you some examples for AI applications. And I also gave you in the sources below the link to the sources where those projects have been carried out. So if you have a look at the slides later on, you can really deep dive into all those fields. But let's start with generation. In generation, we have predictive maintenance. This is a very important thing because energy generation and infrastructure is planned for really long lifetimes, and so it's a huge maintenance task to keep it running all the time when you need electricity. So we have the analysis of acoustic anomalies in hydropower plants, for example. I'll present that in more detail later on. And we have monitoring of PV plants to identify irregularities, to monitor any kind of maintenance needs that might occur there. Then there's the field of yield optimization to get more energy out of the energy generation systems we have in the field out there. For example, in biogas plants, you could use AI to feed them in the most suitable way so they generate more electricity, and sensor networks for optimized blade pitch in wind turbines. For example, in a wind park, you have all those sensors on the windmills, wind turbines, and if you collect all the data and process it together and evaluate that, then you could predict sudden harsh winds. And so all those wind turbines could adjust quickly to optimize energy yield. And the optimization of equipment, for example, the reduction of NOx emissions in gas turbines is a very interesting project where they could, with the existing hardware and just added some software and sensors and artificial intelligence, they could drive down those emissions by 15%, which is quite reasonable. So I
think we're going to have to go a bit faster, actually, okay. Stefan. So we can show that actually it's used all along the value chain, right? So from generation to the consumer services.
Yeah, okay. So I'll do that a bit quicker. In transmission, we also have predictive maintenance to keep the electric grid working, and also planning tools, because you have a very limited amount of data, especially in the low voltage grids. And this data needs to be extrapolated, and there are some AI tools to optimize grid planning. Then in trade, in trade, we have energy generation forecasting. So especially for wind and solar power, we need forecasts of the energy that will be delivered in the near future, and also load forecasting, which becomes more volatile due to electric cars and other industrial applications or heat pumps at buildings. And then there's flexibility trading. So the system needs to be more flexible, and those steerable, controllable components like storages and so on, they need to be traded and bundled together in the most optimal way. So here's another application field. In marketing, we have local energy markets where peer-to-peer platforms appear, which market energy locally in the local grid without saving grid capacity in those transportation grids to make energy management more efficient here, and energy equipment markets with optimized matchmaking of suppliers and customers. in energy consumption, we have all the need to use energy more efficiently, and that's happening through optimized controls, which was quite astonishing. Google could, by the help of an AI tool, drive down its cooling costs of its server farms by 40%, which is really a lot. So there's a huge potential in control mechanisms and controls for plants. Also in buildings, and there's again predictive maintenance of heating equipment, for example, or automated energy consulting. In billing,
and then we have I see for the billing,
prevention.
Yeah.
And
also for the customer services.
Customer service applications.
So as you said, it's really used all over the value chain, which is very interesting. So also could lead to new players also impacting this business. Could be also very interesting to see that happening. Can you just give a very quick example of achievements? Because as I said, we are running a bit out of time.
Yeah.
So
okay. I'll just present you here very quickly to this one project done by Voigt on care. It's an acoustic monitoring of a hydropower plant, and they place sensors and pre-process the data, send it to a cloud, combine it with shared knowledge from the company, and then enable predictive maintenance there, and also supply the operator of this power plant with expert knowledge. And this is a very interesting project which incorporates all the sensors and then the computing of the data up to the service they provide for the power plant company.
Right. And who are mainly those players engaging into this AI for energy?
So they come from 4 major areas. It's the energy utilities, but they mostly apply those solutions. They are equipment manufacturers that integrate AI-driven services like we've seen just, or optimized controls and so on into their equipment. We have the software companies who deliver the software infrastructure, and we have lots of startups in this field who develop new services, new ideas, and everything. And those all need to work together to accomplish the task defined by politics.
And according to you, we see it's a market demand. I mean, there is a very impact on the energy field. AI could be a solution or will be the solution, but what are the barriers to be overcome today?
Okay, so there are some important barriers. One of them is fear of AI application, and this is especially relevant for very small energy utilities who don't have specialized personnel to take on those projects. So capacity building is needed here, documentation and reference projects. This is very important to build trust. Insufficient infrastructure, especially when it comes to sensors and data collection. All those data streams need to be generated at first. So this is also a big need the energy sector is facing anyway. So data needs to be available, and then data needs also to be in a form that allows it to be processed. So the companies need good data governance. And there's also underwhelming performance of AI projects. And this is usually done by happening through great expectations that don't meet the final result. And there are lots of startup companies, like I mentioned, who try to sell their proof of concept, but then it's hard to get this product running in the best way. So those are the most important barriers for AI application in the energy sector. But the main message should be that there's a huge demand-driven market opening up, and that needs solutions that have to be applied here.
Right. Very interesting. Thank you very much, Stefan. Actually, it's a very good spotlight on this energy field because, as you said, it's a climate consideration. It could be also the way to develop new business, maybe for new companies, but also we might see an organization of the value chain because, as you have seen, a lot of different parts of the value chain are impacted and new players are also entering. So it might be also a field that will evolve a lot. Is it what you're expecting?
Yeah, I expect lots of new players to appear there, and new solutions that are really needed here. So the energy system and the energy sector we have known so far with all the big players we know today will look a lot different in 10 to 20 years.
Right. So definitely AI is a revolution. It's a revolution from a technical point of view. It will be also a revolution from the business point of view and for the market point of view. And the question is how to enter into this AI revolution. This is also the goal of this webinar today. And to address these questions, I'm very pleased to welcome Jonathan Byrne from Movidius Intel. And actually, we are very interested in your experience in this because Movidius has been created in 2005, and now you are part of Intel. You've been acquired by Intel, and it could be very interesting to know how yourself you address this era evolution. So, can you give us a bit of your experience on this, Jonathan?
Yeah, sure. So, as you said, the company was started in 2005, and by two guys, David Maloney and Sean Mitchell. They had a small group who were working.
Yeah.
Oh, can you hear me? Okay.
We didn't hear you. Yeah, it's good.
But it was started in 2005 and by a small team who were trying to develop a physics chip for the nascent smartphone market. And although initially they had great success, they managed to develop a chip from design to verification to production for less than €1 million. They got a double whammy in 2008. There was, first of all, the economic crisis, but even bigger was the iPhone came out. And that obliterated the smartphone market. There was lots of companies that were developing smartphones, and that kind of ended. So they did what any good startup does, and they pivoted and decided to look at what was the next big thing. And they realized that cameras were being put into everything. So instead of developing a physics chip, they started focusing on a computer vision chip. So this was the Myriad 1. It was designed to have very low power, very low cost, and could handle the input from multiple cameras. This became a very big success. As of the Myriad 2, it could handle the input from 8 cameras for less than a watt, and could do a lot of computer vision tasks such as edge detection, key point detection, optical flow, collision avoidance, that sort of stuff. Once they got that, it became much bigger. A lot of companies were looking to use this technology, initially Google Tango, and then moving towards DJI. So when DJI came on board, they were looking to build a vision system into the drone, and they took the chip and incorporated it into a product within 6 weeks. So our chips are now in 90% of the drones in the market. We are in nearly all of the DJI drones, not only the high-end drones, but now with the smaller ones like the Tello, we are the main chip in that are doing all the flying and computer vision. But as computer vision progressed beyond 2012, deep learning, which originally came from computer vision, became a very big application area. And so our chip was then adapted to do that. It's still the same Myriad 2 technology, but we're now doing deep learning inference on the edge. So that means we can do it for very low power, for very low cost, and you know, if you compare it for a graphics card that's running at 350 watts and can cost upwards of €700, our chip uses less than a watt and is priced at €5. So it's very easy to use in embedded products. Anything that has a battery, you know, can be using our chip. So one of the things that came out of that was the neural compute stick. This now allows people to use this on a USB stick. They can pop it into any embedded system, such as a camera system, and then they can start taking a trained network and running it on the edge. So this approach has basically piggybacked on top of the computer vision market. Now that there's cameras everywhere, they can oh, sorry, I'm just trying to skip to the next slide. There we go. Yeah, anywhere there's a camera, we can use this to process the information. So where this comes in handy is sorry, just one second. I've just got a bit of lag on the slides here. Yeah, anywhere we're processing the vision information, we can then analyze it before we have to send it back across the network. And this means that we're doing processing on the edge and in real time, and it means that we can do it for much less data throughput. So just to give a bit of background on where deep learning fits, artificial intelligence was big in the 60s. This is where they were trying to think of computers that could think for themselves. As of the 90s, we've kind of scope limited that to machine learning. This is essentially, we tell the algorithm what to do, but not how to do it, and it has to work out how to find its path through based on the data, and deep learning is a subset of that. So I'm aware that we're short on time, so I'm not going to go into a very long rant about deep learning, but essentially what you're doing is you're feeding in data one side and it's classifying it on the far side. What if it is trained on 10 classifications, then it can only classify those 10 things. But this has been very powerful for and very useful in a number of applications. Why it's really taking off at the moment is that whereas traditional techniques only improved a small amount as you added more data, deep learning approaches seem to improve consistently, linearly almost, when you increase the data. And this means we're getting much, much better results as we moved up and added more data. So let's just see. Where this is going to be useful is, yes, there's terabytes of data out there. If you have a security camera, it is generating terabytes of data a week if you're recording and all that and saying on a server. But where it's useful is not just all the data, but if we have actionable data. So, you know, what's the point in sending, you know, RGB information, millions of bytes a week, when all we may need to know is on a security camera, how many people walked by it in an hour? So if you're trying to see how many people are coming in and out of your shop, you could do that in 2 bytes of information and log that every minute. So it's condensing this information at the edge and only reporting what is needed back to the server. And that's where we see a big application area of our technology. So, yeah.
If you have some advices to give, what advices you will give to people who want to enter and to use AI solutions?
What I would warn them is that there is inherent bias in everyone's data. And because of this, what you find is that you should not trust an algorithm blindly. You shouldn't just treat it like a black box. That it can be very brittle if you're not careful about it. I'll give you an example now in a minute. And yeah, if there's a bias in your data, there'll be a bias in your algorithm. So if you have a perfect example was when they trained ImageNet to recognize 1,000 different categories. Some researchers noticed that it was very good at categorizing dogs, huskies from wolves. It could distinguish them very clearly, except for 1 or 2 examples. When they went in and actually picked the network apart, what they found was that it wasn't identifying the dogs, it was identifying snow in the environment. It was actually just, when you have a picture of a wolf on the internet, it's invariably on a background of snow, whereas a picture of a husky is in a back garden with a loving family. So what they thought it was doing was not what it's doing. And you should always investigate what it's coming up with. Second of all, it is brittle in the sense that it will only recognize what you show it. So if you wanted to have an algorithm to, for example, track cars on a road, and you're on an overpass bridge looking down, and you decide to pull 1 million pictures off the web, what you'll find is the pictures in the web have a bias in them. They'll be biased of glamour shots of cars. There'll be nice side profiles of the car, someone trying to sell their car, and it will not be able to recognize those cars from the video footage. You have to train it on the data that it's going to be looking at. And finally, if there's bias in your data, then you will have a biased algorithm. People just, again, think it's a black box or an algorithm is completely objective. But for example, if you train an algorithm to find a CEO based on 200 years worth of CEO data, what you'll find is because there was an inherent bias towards men, thankfully, Geraldine, you're bucking the trend, that you will have that same bias in your algorithm. Amazon, who are absolute experts at deep learning, have had a similar problem recently and they've tried to fix it. They were trying to find engineers based on historical data, and they ended up with a sexist algorithm and they could not fix it. So in the end, they had to shelve it completely because they couldn't tweak it. So these are just things. Don't blindly trust the algorithm, and realize that it only works on what data is passed into it. Okay.
Right. Great, very good. Thank you very much for these very good advices. And again, to the audience, don't hesitate to ask your questions. Meanwhile, I wanted to also highlight, because we are part of this European project, and inSSIght is also dedicated to support player to enter into smart systems. If you want to have access to, for example, the Movidius Intel chips, you can benefit through it through the FAIT for ACE European Commission support. So it's an action dedicated to European SMEs and middle-sized companies to get access to technologies and support to develop demonstrators, to showcase new products to address different industrial fields, from the energy, from the industry, from the health field, from the city management as well. And you can benefit from funding from the European Commission. It's very open framework, meaning that you don't have to spend time waiting for the feedback. We have calls open for companies, and you can totally get access to this Movidius neural computer stick as an example. So if you want to have more information, it's here. It's www.faitforace.eu, and it's again a program from the European Commission dedicated to accelerate access to innovation. So if you want more information here, don't hesitate to ask us as well. So I'd like to thank our experts for their very, very interesting presentation and for picking up their topic, because it was really very interesting. So thank you very much for your very good presentation. And before we go to the questions, I just like to ask you also, participant, your feedback again on if you want to receive more information on inSSIght and also on the presentation today. So don't hesitate to indicate it to us if you want to receive more information on that, so we can send you the presentation. So don't hesitate to answer now. And also, I'm going to ask you your feedback, because it's also very important to get your feedback on the webinar that we are preparing. So just going to ask you when we're going to start the questions. So just, yes, if you can evaluate the webinar for you, it will be very interesting for us. So in terms of questions, we received a few questions during the webinar, and we would like to see that with you. So maybe our expert can answer some of the questions. I know that we are running out of time, but it could be interesting. We have a question from, oh, sorry, because some people left already. So we have a question, but it's okay, we can answer it in any case. Do you think, Johan, do you think that AI is not necessary for motion control? Do you think that there is good enough solution today?
Yes, I mean, for now, what you need for motion sensing does not I mean, and more generally, you don't need AI to gain accuracy in motion sensing for now. At least for what we are doing in gaming, for example, that's enough. And even if artificial intelligence is a hype and it's a very nice world, if you can do something very easily, why do you use AI? So for now, motion sensing, you don't need AI, clearly. And there is plenty of domain that doesn't need AI, even in imaging with very powerful and very nice computer vision algorithms. So yes, motion sensing is an example, but you have plenty of example where you don't need. And I mean, if you look at the Mobileye, Movidius, they have done that for years before AI, and that worked very, very, very well.
We have also another question for you. You make us very good presentation based on the consumer application. I think you are launching a report in the coming days or weeks.
The reports have been released already for consumer 3 weeks ago, something like that.
3 weeks ago. Okay, sorry for that.
No, that's
and
fine.
The question is, do you have plan to have report on digital application upcoming?
So the next one will be on automotive, which is we didn't speak today about automotive, but clearly for artificial intelligence, it's a huge opportunities, and we will have maybe something about industrial at the end of next year. But the main domains for artificial intelligence that we have at least spotted from our side are consumer, as I said, automotive, and medical, where there is very great things there. Industrial, there is some stuff that are very interesting, but it's still a niche market for artificial intelligence.
All right. Okay, thank you very much. Stefan, you made us a very good presentation on energy. I think you're also preparing a report, a paper actually on this topic. Can you give us a bit more information on that?
Yeah, we're actually working at the moment on a little policy paper on the topic of energy or AI application in the energy field. And that will be released in German, unfortunately only, but it will be released in the beginning of next year.
Okay, very good, very interesting. So we can have access to it through your website.
Yeah, that will be freely available on the internet.
Okay, great. Thank you very much for that. I know time is running, so you don't hesitate to ask your questions. We will answer to you by email directly. And I take the opportunity also to invite you to join the smart systems ecosystems and the inSSIght ecosystems, as you can see on this slide. Oh, yes, we have a question from Petra Weller. Petra is the coordinator of inSSIght, and Petra is currently at Effect event with a part of the consortium. So, hi, Petra, and I'm going to ask your question. So, the question from Petra is, what would be the recommendation for the smart system community to address this topic together with others? Maybe you can all answer. Maybe we can start by Jonathan. How do you think that the people that are part of the smart sensors, so mainly sensors activities, hardware, but also algorithms, can work all together to better address this AI revolution?
That's a really interesting question. I think it comes down to kind of collaboration and working with shared data sets. Like, we can optimize based on network and topologies for what we know, but unless we have the data sets to work with and the networks to work with, it becomes quite tricky. A lot of what we do is fine tuning to get the speed for a particular sensor solution. So I think only by closer collaboration can we really get better improvement out of that. Data sharing as well. You know, a lot of sites like Kaggle, for example, are now basically setting up challenges where multiple people compete on a problem, and that really drives the field forward because everyone's learning from each other and how best to tune the algorithm to work on the data.
Good. Okay. Actually, that's very good advice. Yes, thank you very much for that. Very interesting. So now time is really running, so I really encourage you to join us at SSI Ecosystems and the inSSIght ecosystem. You can benefit from research priority, roadmap, strategic roadmap, also from the EPOS group, and also policy position. Don't hesitate to share your feedback. And again, welcome to the inSSIght website. So it's inSSIght.eu, and you will have also here all the webinars that have been organized by the inSSIght project. So thank you very much for this very good presentation to our speakers today. It was a great honor to have you with us. Thank you very much.
Thank you.
Thank you, Geraldine. Thank you very much.
Thank you, and thank you to the participants. Thank you for answering our questions, and we will send you the answers, but also the presentation from today. Thank you very much, and wishing you a very good afternoon. Thank you. Bye.
Bye. Bye.
Bye-bye.